City the size of London. But could it really happen? Well, Austin Atkinson is this week publishing a book, Impact Earth. He joins me now. Good morning.
Hello, Sophie.
This always sounds, when you talk about asteroids hitting Earth, it always sounds like sort of those latest Hollywood films. What is it?
Yes.
Deep Impact?
And Armageddon, yes.
Armageddon.
They were probably pretty good movies. They were quite useful because they encouraged NASA to increase funding, or actually put funding into looking for asteroids and comets, where really funding didn't exist before. So they did actually serve a purpose, as well as helping Bruce Willis's bank account.
So it's not just sort of a good storyline for Hollywood then, it could actually happen?
It could actually happen, certainly. There's a recent government paper which has been published talking about how there might be a 1 in 20,000 risk of dying from an impact sometime in your lifespan, which is roughly analogous to dying from an aircraft crash or something of that sort. So there is a real risk. It's not just fantasy, it's not just pie in the sky, it's actually potentially a real hazard.
All right, we've got some lovely pictures floating behind us here. Just
Yes.
explain, first of all, what they actually are. Asteroids, meteors, what's the difference?
Well, this looks like, potentially this is the asteroid belt, which is somewhere out between Mars and Jupiter, by the look of it. And essentially an asteroid is a lump of space rock, really a mountain of rock in space. It could be composed of just rock, or iron and rock, or just iron, and with other minerals. So they can be extremely heavy and very dense. A comet is more a ball of ice, a huge ball of ice and dust which have coalesced probably 4.5 billion years ago when the solar system was first created. And here we see a comet which is clearly heading through the outer gas giants towards Earth. And comets give off these huge trails when they approach the sun because the ice is melting effectively, and that gives this beautiful display. Asteroids are probably the most likely hazard because there's an awful lot more of them. Government papers suggest that there might be as many as 2,000 1-kilometre objects out there, maybe 8,500 metre, and maybe 1.5 million or more at 50 metre in scale.
How, I mean, some things have actually landed on Earth.
Oh yes, many a time.
Quite an impact.
We're constantly being bombarded by absolutely tiny pieces of rock which cause no problems whatsoever and often burn up in the atmosphere. We sometimes see a shooting star. Sometimes bigger ones actually do penetrate. A 50-metre object might get pretty close to the ground, and one happened in 1908, which caused...
1908?
Yeah,
right.
Which caused huge devastation in Siberia. It's called Tunguska, a bit of an urban myth now. But it went off with the equivalent of 5 Hiroshima bombs, somewhere about 8 kilometres above the ground.
And was that the last near miss, or...?
Certainly there was an instance in about 35 in Brazil where some objects exploded, probably asteroids, in the atmosphere, and laid some of the jungle to waste. And local tribes thought it was a visitation from God, I think.
Well, considering the impact, as you say, that these could have, why isn't more being done to protect us?
It's a very new science. There's a team in America called Louis and Walter Alvarez. They were a father and son team who first hypothesized the dinosaurs were killed by an asteroid impact in 7980. So you can bear in mind that that was only 20 years ago, and it takes a long time for science to catch up. We're only really just beginning to understand that it's not a threat that died out 65 million years ago. It's going on now. We're constantly being bombarded, and of course we're quite likely to be hit by a relatively large one.
But it does sound terribly frightening to people hearing what you're saying there,
Yes.
the likelihood of being hit by a large asteroid or something like that.
Yeah, I'm still paying into my pension, so don't worry.
So you think we're going to be here for a while, good. But I mean, they can, if scientists spot one coming
Yes.
towards Earth, I mean, it's a long way off, isn't it? I mean, they can predict it, am I right in saying
not necessarily.
several years?
This is one of the problems, because it's really only the Americans, God bless them, who are looking for this, for these threats. There are rather large gaps of examination of the sky, particularly in Australia. Nobody's looking at the moment.
But if the Americans, let's say, if the Americans are training their telescopes on space,
Yes.
they spot something coming towards Earth, they can take action.
Potentially, yes, we might be able to do something. We have nuclear warheads. We could set them atop huge rockets of the Apollo type, maybe larger, and perhaps fire them towards these objects and redirect them. Not necessarily destroy them, but certainly use the thrust from a nuclear bomb to steer them out of the way. Of course, right now, there's not even any political agreement in place to begin discussing that. There's an outer space treaty signed in '67 distinctly forbidding nuclear weapons in space, so we've got a long way to go before we can even think of doing that.
How seriously is it being taken in Britain? If the Americans are training their telescopes in space, what about us?
We're beginning to. We're always lag behind our American cousins, unfortunately. But I have to say, in the Blair government's favour, we are beginning to take responsible action. And
is it as simple, literally, as training a telescope on space?
It could be, yes. I think the fact remains that the more we look, the more likely it is we're going to detect something earlier and maybe be able to do something about it before it actually hits. If we don't look, we won't be able to do anything.
But people, as you say, shouldn't be too worried, shouldn't be panicked by this.
There's no point. I mean, we could die from an
You're still paying into
earthquake.
your pension fund, as
exactly.
you say. Okay.
But
And you're an expert on it. Okay. Thank you very much for joining us this morning. Now, British technology is helping New York build a state-of-the-art planetarium. Visitors to the Hayden Planetarium will be able to navigate through a scientifically accurate three-dimensional map of our galaxy, the Milky Way, for the very first time.
Planetariums have entered the digital age. London was the first to have a digital projector in Europe, but advanced technology will make our computer-simulated galaxy so accurate, people will see exactly the same sights as from space. The European Space Agency's star mapping satellite Hipparcos has charted more than 100,000 astronomical objects. New York's planetarium is reconstructing these positions using the latest computer software, and they're using the Hemispherium in Teesside as a test bed.
The planetarium in New York is going to be 21 metres, ours is only 6 metres, and they're going to use 7 projectors, and the only place in the world right now that has a dome with 7 projectors is ours.
The Hemispherium was designed and installed by flight simulator experts Trimension. They beat off worldwide competition to provide software and technology for New York's larger version of Teesside's dome.
We've got a drop-dead date of the 31st of December, the millennium. A big party is planned, and at that point we want to be able to show the museum trustees, NASA and the public and the press a working digital planetarium with a model of the entire galaxy.
The Milky Way contains billions of stars, so the digital galaxy map can be updated for a more realistic journey through space.
Planetariums traditionally, ever since their inception, provided a view of the universe that was basically the view from Earth of the night sky. We will now be able to look at that night sky just as we always imagine that the stars are at great distances and so forth, and we'll be able to set course in any direction at will and fly off, just as the Starship Enterprise does, off to various quadrants of our galaxy and beyond.
Planetariums, like the one behind me in London, are great for taking people on a cosmic sightseeing tour. But by using real data from satellites to pinpoint the exact position of stars, the one in New York is setting a new standard for the next generation of planetariums. Sue Nelson, BBC News.
Now, just staying with the subject of technology, because on Monday we're going to be discussing the issue of GM foods. Many of the papers this morning, headlines here.